for the panel discussion on IndiaAI large language models. I would like to call upon the esteemed panelists onto the dais now. Mr. Srinivas Narayanan, Vice President, OpenAI. Mr. Amitabh Nag, CEO, Bhashni. Ms. Shalini Kapoor, Director, Asia Pacific and Chief Technologist, AWS. Dr. Mohit Sevak, AI Researcher and Developer Relation Manager in NVIDIA. Dr. Kalika Bali, Principal Researcher, Microsoft. Professor Ganesh Ramakrishnan, IIT Mumbai. Dr. Pratyush Kumar, Co-founder, Sarvam AI. Welcome you all for the session. I would request all the panelists to please come in front for a photograph. Thank you. And now to guide us through the excited and insightful session, I'm pleased to hand over the proceeding to Mr. Amitabh Nag. Mr. Nag is in his role as the CEO of Digital India Bhashni Division and Director of Digital India Corporation, holds the responsibility of spearheading the implementation of National Language Translation Mission, aims at breaking language barriers. Mr. Nag, please take over. Thank you, everyone.
Thank you very much, ladies and gentlemen. Very good morning. Right. It's my pleasure to welcome you all in this inaugural panel discussion about India AI large language models in the Global India AI Summit 2024. So as you know, India AI mission has got 7 pillars, and those will be up in the screen in a while. Those 7 pillars are basically related to the compute infrastructure, foundation models, data sets, because otherwise the foundation models will not, be built up. Application development, which is basically all about use cases. Future skills, building skills around, the AI and ML technologies. And also encouraging the startups to build applications to work on this particular thing, either in the foundation model space or in the application or the use case space. All these needs to be safe and trustworthy. So those are the 7 pillars which you see, which we are talking about. And specifically when we are looking at the, foundation models, we are talking about the India Innovation Center, which is the core of the foundation model, which is actually has the objective of contextualizing and building India, India-centric or India-unique AI models. It is also looking at building talent around it, unique AI talent which can actually build this or take this forward in terms of Indian context. The idea of the entire thing is to make AI in India and make AI for India. So it's basically looking at a unique plethora of models, use cases, and related research and related development activities which are going to be there. The foundation models will require large resource and, there will be certain priority sectors in which we would like the AI to actually benefit people. This is in line with our DPI principles where we have used internet and technology to benefit the end users rather than, looking at it for advertisement or any other, information display play. It has to benefit the last mile. And obviously, we are also looking at democratizing the data which is there in the government by anonymizing it and, annotating and labeling it. So that's another area because data is the oil for, the AI setup. Now, this AI revolution which is going to come is perhaps in its instance, one of the major revolution after the industrial revolution, and a lot of things would change. And the India AI program is, in its 7 pillars, is exactly designed to address all of it. It covers holistically, as we said, and as Honorable Minister also mentioned in the morning, covering the base thing that is compute, data sets, foundation model, skills, applications or use cases, spurring the startups to build new applications, and also to actually look at the rest of the activities with respect to safe and trusted setup here. So with this objective, and what Innovation Center is supposed to do in terms of building contextualized foundation models, retaining top AI talent, ensuring that you have high resources which are there, and the application and the use cases for the priority sectors, and hence also having the data sets which are democratized. We are looking at a next revolution where India will be stepping ahead in terms of what needs to be done and how it can be done. So the session which we are right now having here, and that is where we will get into, is looking at 4 major, objectives. One objective is to take the global perspective, what is happening in this space of large language models, the multimodal perspective, the way, the accuracy or hallucination or whatever things we look at the challenges part of it and the potential part of it as far as that is concerned. That's taking the global perspective. Looking at how do we develop the large language models in the linguistic and cultural diversity which we have. India has 22 languages plus, means there are about 100 languages which are spoken by 100,000 plus people. There are different cultural requirements which are there. Are these large language models will be in a position to build that up? Then, of course, we did talk about the challenges since morning. It's about ethical and bias associated with the large language models. How can we make it bias-free? How can we ensure that, it is having, though the cultural ethos, but it is bias-free? And then looking at how do we collaborate with the opportunities which exist with academia, industry, startups, all these different entities which have, and each one of them will be touched by this revolution which is coming from the artificial intelligence. So at the first instance, to look at what global perspective is, you heard Srinivas in the morning. I would invite him for the keynote on this to tell us what is the global perspective as well as what can be the Indian context to it. Srinivas, please.
Thank you. Yeah, again, it's a great honor to be here. I will say a little bit about sort of where we are with LLMs and some of the unique context around India. I think it's a incredible time to be working in this field. I started my journey in AI in the 90s, as I mentioned earlier in my talk, and I never expected that, I'd be here 30 years later and in the middle of probably the most important technological revolution of our times. And so it's just an amazing opportunity. And of course, we have to steer this in a safe and responsible way. I'll talk about that in a second. Our mission at OpenAI is to build AGI that is safe and make it beneficial for all of humanity. And when we launched ChatGPT about 1.5 years ago, we honestly didn't expect it to be this successful. We thought it would be a low-key research preview, but it has just really taken the world by storm, and we see an incredible amount of usage by all sorts of communities all over the world. People are using it to write code. People are using it to write different documents and emails. People are using it for analyzing data. And then the variety in use case has been really spectacular. So I think for the first time, we are seeing truly generalized intelligent models that are able to reason in context and do things on our behalf that are making us really productive. I think that's just an exciting opportunity overall. And there are many studies that we have done that shows that the improvement in productivities is very significant. Like in many areas, it's on the order of 40%, 50% productivity. And when you think about that, when every job can be made more productive, I think this is probably going to drive a huge amount of economic progress in all sorts of areas. I think the other exciting possibility here is that this has created a completely new interface to computing, right? It's a more natural way to engage with technology that is conversational, whether it's through language or through speech. And when you have a natural interface to interact with technology, I think you are making it a lot more accessible. So a lot more people can interface with it and use it to get things done. And I think for the truly first time, ability to interface with technology in a natural way is happening, and that's, I think, also really, really exciting. The other big shift and trend I will probably talk about a little bit is that we have ChatGPT as a product, but we also have developer APIs. And in both these things, one really interesting trend we are seeing is that the current technology is allowing us to answer questions, right? So you ask ChatGPT or any of these AI models any question you have, and you're getting answers back as opposed to just search queries and results. And that's exciting because getting succinct answers is useful. But we're going to see a shift also from answering questions to taking actions. And we're seeing in the very early stages of that, some of our models are good at calling functions, and people are using it in very, very creative ways to be able to call functions on your behalf. We have examples of companies using it to generate posters on demand. We have examples of functions using it for customer service, where you're able to understand what your customers want and be able to query what the status of their order is, automatically maybe do refunds, etc. And so the ability to take actions is also something that's exciting, and I think we're going to see a lot of progress towards that in the future. Couple of things specific to the India context. I mean, language is obviously very top of mind for us. Cost is very top of mind for us. So these are two pieces of feedback we've received from the community over the last year. And GPT-4o was primarily done to address a lot of this feedback, right? We made the price of using AI a lot cheaper than in the past. And that has just, again, opened up access to a lot of people. We are able to serve our best quality models in our free tier. So a lot more people in the world are able to experience the leading edge AI, which has been really exciting. And also for developers, it has really brought down the cost of building new applications. And that's been, I think, it's going to create a lot more opportunities for innovation across of lots of different developers as well. And languages, I think, is obviously very important in an Indian context. We have so many different languages. So GPT-4o was, again, it improved the performance on Indic languages by quite a bit. Again, that's because of the effort we put in to improve the data sets. We also improved the tokenizer so that in many Indian languages, we are using about 3 times fewer tokens in GPT, the latest model GPT-4o compared to before. Okay? That's also an additional savings in cost. And these are things that are really driven by feedback from the Indian community. And how we think about data is obviously going to be important for us going forward as well, and we're super committed to doing that. And I think we want to improve our models for the use cases that we care about for India. I think we touched upon safety. I'll talk about that briefly as well. Safety is really important. It's a really important part of our mission. And we think about safety in every step of the process. So right from how we curate data sets for pre-training, how we use red teaming, and how we shape the reward functions for aligning AI systems. And we also do robust monitoring of our AI products when we deploy them in the real world to make sure that these are being deployed in a safe way. And of course, this is going to be a theme that we're going to continue to work on as we have future systems. We really think about safety from the first principles. And we also have a preparedness framework that thinks about frontier model risk and how do we want to think about them and evaluate future models from these risk perspective. And that's something we do on an ongoing basis and every day. And it's deeply embedded into our ethos. And I think that's really critical as we shape the future of this technology. So I think, again, this is an incredible opportunity. It's the most important technological evolution of our times. And I think it's amazing to see the creative energy in India. I interact with lots of developers, and their ambition is amazing, and it's very inspiring to see people taking on really, really hard challenges, right from education to healthcare to agriculture and innovation and software engineering. And I think the opportunities are enormous, and it's amazing to work with all of these folks. And We're here to help India and the India AI mission. And one of the things we are excited to do is to also further the application development initiative of the India AI mission. We are here to help in whatever way, whether it's providing access to models, whether it's helping shape the thinking there. And I think that's going to be exciting to see AI being put to use for all these really important societal scale challenges. Providing expertise at scale is one of the hardest things that we grapple with as a society, right? We have people who need more, we need more doctors, we need more lawyers, we need more teachers. And I think AI can help us with all of these things and help us do our jobs better with helping humans be more productive. And I think that'll help us scale the expertise as well. And we are really committed to helping India and scaling the benefits of AI for everybody. Thank you.
Thank you, Mr. Narayan, for the insightful keynote covering various aspects related to AI. I would request Mr. Nag to please felicitate the keynote speaker. Thank you. Sir, it's over to you now.
Thank you very much, Shubhi. And just to kickstart the panel discussion now, let me come to you. Sure, thank you. Sure, thank you. Pratyush, I'll come to you first. You have been part of AI for Bharat, and your association with Bhashini is cherished. A lot of things which you have done in open source, which actually takes this thing. So tell us something about what could be the best practice of leveraging open source to build this, foundation models, or the large language models which we are talking about. And how can we talked about scale, will it scale, how will it scale, and all those questions which are there. So over to you, Pritesh.
Thanks for inviting me here. No, firstly, we should recognize that this is a very new technology. It's just a few years old, and there's a very, very long evolution that we are on for the technology to get better and become more useful, right? The first thing to do is to be very optimistic about the value that will be created with this technology. Already, like Srinivas said, many things are being done and much more could be done. So it becomes very important for us as a country also to think about how to ensure that this is available as readily, as easily for people to use, modify, and build on top of. And that's where open source as a movement in computing has been very strong. And kudos to the government of India. I think the Bhashini project has been a big success in demonstrating how to do open source Indian language AI at scale, right? I don't know how many of you are aware of it, but if you go to the website, you will actually get data sets, models, ideas of applications, etc., for a range of tasks, whether it is translation, speech recognition across languages. We have also played a small part as part of AI for Bharat, which is a center at IIT Madras. But large language models, they sort of like up the game a bit in terms of the need for compute, the need for data, and also the need for expertise to build it, right? So all of these axes have gone up. So it's very important, therefore, to also repeat that with this new technology, have all the resources that we need, whether it is the large data sets in terms of training this text and even multimodal models, have sufficient compute, because this is very compute hungry. All of you know about, I think we'll hear from you also about the NVIDIA GPUs. This is really very compute hungry, and in a scale that is very different from what academia and research has seen in the past, right? And the third thing is expertise, right? I think with every passing week, more people know how to build these models, but it has actually been a small set of people who have built the technology, right? So being able to open source, not just the resources in terms of data, but also the tooling around building these models, open source the ideas of how these models are built end to end, right? There are lots of little bit secret sauces here and there that get sprinkled to get the models to do well. And also open source the machinery to use this tool to build applications, right? Not everybody builds an operating system, even though operating systems are open source, but a lot of people leverage what an operating system provides to build applications of various kinds, right? So being able to build applications on top, which is not just about the single model, but the sort of the orchestration around it, and also being able to fine-tune these models for tasks, right? So my sense, Amitabh, would be that we need to have a similar movement to create all these artifacts in the complete open source with very permissive license, whether it is text data, whether it is image data, audio data, etc. Have the compute to make a few large bets in terms of building these models, and then sort of open source the whole end-to-end experience of it. Of course, this has to be representative of the culture, representative of our language, and so on. I would also like to just end with one comment. The cost of doing something like this is rapidly decreasing, right? From 2 points of view. One is compute is becoming increasingly efficient, right? And secondly, even the way we think about data is changing. You can get access to lots of data in interesting ways, which can be used to kickstart something like this at scale, right? Yeah, I would just start with that. Yeah.
Thank you, Pratyush. Taking cue from that, Shalini, I would like to come to you, as Chief Technology Officer of AWS and a person who would have seen such large language model across many countries. There is a problem of data which consistently and continuously come up, and we actually talk about data scarcity rather than data availability. How do you think this challenge can be taken up and, and we can, come to a situation where we have enough data to train the model, enough perhaps will be an overstatement, but sufficient data to train the model and get the desired result on it?
Sure. So I think I would like to focus on the fact that, while we are sourcing data and creating LLMs, what is going to be the success criteria of an LLM? The success metrics is going to be the usage as to how we use the LLM. First of all, there is not going to be any single LLM which will rule the world. I mean, there are a lot of stats which come out. Today this LLM is better, tomorrow that is better. There is going to be multitude of LLMs for specific domain, for specific region, for specific needs that every citizen in that part of the world will have. And I'll share some experiences across the globe. Like we have worked in Sea Lion. Sea Lion is Southeast Asian languages, and how we are sourcing, different languages with Thailand, Indonesia, Singapore, and things are so different. Like, if you say lol in English, right? It is laugh out loud, laugh out loud. But in Thailand, you actually use a term 55555, which means laugh, right? So it's a very specific to a particular language. And then we also have experience in India. We are working with Ola Kitrim, where it's about Indian languages. It's about how Indian languages talk about lol or for any other specific thing that we might have. And then also we worked in Falcon. Falcon is used in Middle East, and it's a very highly trained model catering to that area. And what we have seen across all these examples is that one, setting up the data pipeline, sourcing the right data, that is definitely very relevant. But what is important is that while you are creating the model, you have looked at various parameters of the data so that it's not biased. It is not biased towards a certain specific gender or race or religion. So the bias mitigation part of it, and also how easy it is to use the APIs and make it available in usage. For example, if you see today UPI, each one of us is using because it's simple, because it's available, its APIs are available and easily accessible. So the usage of a model is going to define the data as well, and that is going to pump up the data creation, the data feeding into it with bias mitigation, and that's going to make a complete model. And some of the other examples are in healthcare, in education, and agriculture. And I'll take an example of work that we are doing in agri, which is a micro LLM, which is we are creating. Now, micro LLM for climate predictions or, climate for various crops to a farmer is so important. But a farmer doesn't talk in English. The farmer listens or wants to understand information across, it could be Telangana, it could be Karnataka, it could be spread across the country. But a lot of climate prediction and climate satellite systems are in English, right? I mean, that's how the source of, that's where the data is lying. So, we worked with Cropin, who's our partner, and they took English. They actually took English first and they said, let's solve the problem because it's a domain, it's language and domain which we have to solve, but they fully recognize the fact that it has to be solved. The interactions have to be in various languages. It could be Malayalam, Hindi, etc. So how do you marry the domain of an agriculture to a language where there would be various nuances and various dialects which would be available? Now that is a complex problem, and there you have to have data which is agriculture, which could be in English fed from behind, but actually you are conversing in a different language. And a similar thing in healthcare, right? If you look at the data, a doctor writes a prescription. So doctor might write in combination of English and Tamil, right? So the patient might say, I have jwar. Jwar is fever. Now, that is used in various languages. Jwar as a word is used in various languages. But now you have to marry healthcare, you have to marry the fact that the medicine is, and it's a domain-centric information which is available, which is about medicine, about disease or condition that a patient is talking about. The data could be audio, and the data could be even video or textual. So there is, that's a complexity again. So how to create a model which understands domain, which solves the problem for language. So there would be not a, again I'm saying there will be no single model which might solve the problem. You might need multitude of models to solve a problem so that the usage increases. So to increase the usage, to take it to citizens at scale in an environment where everybody is using it for some medical condition, or everybody is using for a disease prediction on a particular crop kind, you need the domain as well as the language solutions and the data which is present in both the things, but you are able to create the pipelines and solve it for the usage. So, I'm just trying to paint the picture as to, how we need to all solve it together.
Thank you, Shalini. And few important things which is there that which she talked about. One was use case centricity when you are doing data collection. You can't, if you're doing data collection, you need to know what it would be used for. So that is a very important aspect. And, look at it. The second thing which was, which she talked about, which is there about, marrying language with domain. And you might find data in a different language, and the user or the beneficiary might be absolutely using different language, and that too multimodally. It can be text, voice, etc., etc. And hence, multiple models need to be used in that context. Now, taking this context, Professor Ganesh, I'll come to you. IIT Bombay has, now moved on to create what could be the Bharat GPT. There are different strategies which people talked about. You could create a large language model in a specific language. Each means each of the languages, or you can create in one language and use translation models. How could all the stakeholders collaborate in this particular area to make this? What has been your experience, although it's initial days, but how are you going about it?
Thanks, Amitabh. I think the key word here with Bharat GPT is public-private partnership. And I'm going to emphasize the role that the public and the private play. I'm very grateful to the Department of Science and Technology, the NMI CPS program, Dr. Ekta Kapoor is here, who have actually enabled this in the first place. And this is a consortium consisting of several academic institutions. IIT Bombay, we are the leading, but we also have IIT Hyderabad, IIIT Hyderabad, IIT Kanpur, IIT Madras, IIT Mandi. We also have a management institute, I am Indore, and then Bhashini. So this, in some sense, is a large consortium. Additionally, we have the entire thing pivoted through a Section 8 company, the Technology Innovation Hub at IIT Bombay, which also makes it possible for us to run multiple programs and capacity building. That point was actually emphasized a couple of times, and Pratyush also talked about it. The Secretary Mighty, in fact, made a very emphatic point about India actually being there, top up there in skill development. But we really need a lot more skilled people. So the Bharat GPT program, one, bringing consortia together, creating a consortia, bringing academia together, so that the open source culture, the substratum of all of this, actually can be facilitated from the word go through proper permissive licenses, as Pratyush also pointed out. I would also like to emphasize here that the focus need not be only on data. There has to be also sufficient focus on innovating on the algorithmic front. And I'm going to give, taking cue from Shalini, right, take some examples of how we've actually found innovation in the algorithm front very complementary to dealing with resource constraint settings, for example, sparse data. Now, Amitabh alluded to this. He said the amount of data we would have across Indian languages would still be limited today. Whether it's sufficient, well, algorithms can also determine that. So how about exploiting the lexico-syntactic similarity across Indian languages, the phonological similarity across Indian languages? Srinivas also talked about how the number of tokens that got reduced to 1/3 by leveraging. Now, a lot more can be done there, and that's where, through this academic industrial collaboration, we get the bandwidth to do this deep thinking. And thankfully, we have made significant progress. And it's not just the Bharat GPT work itself. We've also been very thankfully leveraging all the previous collaborations. With Amazon, for example, we had a very successful project where we were able to adapt to speakers or accents of languages which have very less representation. How do you adapt to Manipuri accented English? Right? And you can do that because if you have targeted selection, if you know algorithmically that there are a bunch of other accents that come close to Manipuri, Assamese, Bengali, we're able to quickly learn. So in addition to publications, we also have put out an open source platform, decile.org, decile.org, like percentile, you have decile. And there are very important components there implemented all to C++ and with very good documentation, which enable you to do what we call subset selection, identify a subset of the data that's as good or representative and diverse so that we minimize chances of bias, bring in targeted scenarios. I can do targeted subset selection, bring in the ability to do data programming where you have the human designed rules of logic coexist with the deep models, including large language models. And the interesting thing is there are actually many products that have come out even before Bharat GPT based on the decile.org platform. And that's where the vertical, right? It's important for the academia to be engaged with the industry. That's where the vertical comes in. Amitabh rightly pointed out the kind of data we are seeking should be determined by the applications. So just based on my own experiences in the past working with Bhashini, and thankfully we've been very grateful to have several associations with Bhashini in text and speech domain and optical character recognition domain. For example, we had this project called udanproject.org, which predated Bhashini. And the need there was being able to digitize and translate, make textbooks available in Indian languages. Now, even you're translating a textbook in mechanics in Indian languages, you actually need to make sure that the translations respect the terminology of the domain. Now, are you going to train domain-specific translation models for each language, for each domain? It's simply not possible. Well, we were able to do that through constrained dictionaries, ingest dictionaries as constraints on the fly, right? And that became very successful. In fact, there are large number of adapters of the Udan project. It's all open source. The models that we built out are all part of Bhashini, the Ulka framework. And what is important is that gives control. I really like the minister's topic, human centricity and inclusive AI, right? He brought in this phrase. So how can the translator feel in control of the output that is generated and being able to meddle with the output in a way that the model learns? So thankfully, the Udan project actually got adapted. There's a company that has come out, and this company is now engaging with very vertical application, very domain-specific applications, for example, with ICICI Lombard, the company is called BBS Tech. And it has actually brought in this programming, data programming in production environments. And the keyword Srinivas used was taking action, right? Actually being able to take action in a very, very specific domain by giving control in the hands of the human. We say data is less, but the problem is in such domains, the data is even less. In business-centric environments, the data is even less, and you're not supposed to have access to the data. How do you distill out the human information, be able to encode them in the form of programs? So this is some of the experiences we had, and I think it's very important to emphasize industry, academia must collaborate to make AI actually usable and inclusive for India.
Thank you, Ganesh. And I think very important points which were made across with some examples and the interactions which is there. So, taking cue from all of this, Kalika, I'll come to you, as one of the ground, researcher who has been working on ground for such a long time, a lot of experience. What we would like to know is that, and of course the experience from Microsoft also helps you a lot, is how could this large language model actually accurately represent the cultural nuances and traditions? How does this happen, or is it at all possible? Because the underlying language which we are using most of the time is English. Will it ever be representing the culture and ethos of the different languages which are there?
Yeah, I think that's a really good point, and I would include things like bias and harm as part of this whole cultural discussion. Right now, I would think of these very large language models with respect to specific cultures as having an outsider's view of the culture. So it's not as if they do not know, you can't go and say that these large language models know nothing about Indian culture, because the minute you say something like you're working on culture alignment, people will say, oh, but I did this, and I prompted it for this, and I got, I asked it to create a picture of a goddess, Indian goddess, and it created such a beautiful picture. Now, I would like to ask everyone here that, is it the case that the minute you say Indian goddess, are like multiple hands the first thing that come into your mind? Probably not. But from an outsider's view of Indian culture, the thing that probably strikes them the most is the multiple hands of Indian gods and goddesses, right? So when we are talking about cultural alignment, we have to have an insider's view of what the culture is. What is the culture that we are representing, right? And similarly, it relates to the harm or the bias that we might have. I personally do not think that we can ever have a bias-free system. We can only hope to mitigate the bias as far as possible. And it becomes really complicated when we have a plethora of languages and cultural representations, because think about it. We have a language which will represent every object with either a feminine or a masculine gender, right? Then we have a language which will have no gender at all, right? And then we will have a language which will have gender in the pronouns but not in the verbs. Look, so there is so much complexity in the way even the something as simple as gender is encoded in the various languages of India, that when we are talking about the data collection, we have to be sensitive to that. We have to also be sensitive to the distribution of the data that we are collecting. Is the distribution aligned with what we seek to represent? And therein lies, like the, Pratyush talked about, it's not just data, there's also like some secret sauces all over the place. And, maybe data is one thing, and we are getting very good at, thanks to all the efforts by the government and various organizations associated with this, we're getting very good at the data part of it. But maybe we need to understand better what these secret sauces might be, to appropriately use the data to be more culturally aligned, to have more biases identified. And can I also say one thing about the bias part of it? There is no definition, there's no agreed upon framework for what bias is in our context, right? And I was just talking to someone just outside this hall, and I was saying that, I hope that if I say that a woman cannot go into a career and attain professional success, if I make a statement like this here in this room, most people will call it biased statements. At least I hope everyone will call it a biased statement. But, you just have to step out and, go a little kilometers down the road, and you will find that there are many women who will also agree to this. So, how do we take such a fuzzy concept as, say, discrimination, bias, and culture, and actually extract structural and, metric-oriented framework of how we define this, how we identify us, and then how do we mitigate it? And I think that requires everybody coming together to make it happen.
Thank you, Kalika. Yeah, it's a complex subject, but I think you alluded to it quite well. And of course, there are perspectives and there will be perspectives which will be there, and each one of them will have its own logic as it been happening. Mohit, now coming to you, you have been the people who have actually, as NVIDIA, propelled this revolution, so as to say, because unless the hardware was there, it wouldn't have been possible today. So putting across the question back to you in terms of, what could be the innovative approaches and technologies which can address the challenge of building the foundation model? You might have solved a few, but what could be a few more which you can, give examples to this particular gathering?
As I rightly said earlier, India has around 23 official languages. But the Bharat that I am proud to represent speaks around 10,500 unique dialects across 123 unique languages. The largest model that I am aware of can deal with even 100 of languages, has a tokenizer vocabulary size of 254,000. The most popular large language model, GPT, that we talk about, even in its latest avatar, supports only 1 lakh tokenizer vocabulary limit. Any model that is required to deal with such a complexity of languages, or these number of languages, need to the bare minimum just for the spoken languages that humans speak, at least this size of a tokenizer vocabulary limit of 254,000. If you add to it the bread and butter of Indian service sector, which is the IT, the coding languages that we talk, we speak, we write, that takes us to more than around 180 languages. Moreover, my Bharat is not as comfortable in writing languages. It is more comfortable communicating through spoken languages. My Bharat speaks more comfortably than it could write. Which means now I'm not talking in the realm of the text of large language models, but I'm talking about in the realm of large communication models. Or to be more precise, large multimodal models. Just to excite your right hemisphere more, let me give you some more numbers around it. So the model that I talked about has around 254,000 vocabulary size in its tokenizer. Also is as large as around 540 billion parameters. But that model is not very popular. Because in the state of the art, if you want a model to do multiple things, and do complex things, complex reasoning, complex language translations, you require something called as a mixture of models, which is 7 to 8 models of the same size working together. So the GPT, as we know as together now, is actually 8 different models, each of size 220 billion parameters. If we are talking about a model which can understand the range of our languages, that will be around 540 billion parameter each. If we want it to do the type of tasks that we are used to with GPT and other things, we have to get 8 models of that particular size. Even at a very conservative target, we are looking at 500 billion parameters into 8, which comes to the territory of 4 trillion parameters as a total model size. Even if we take a very conservative approach, let's not take 4 trillion, let's take something in trillions. These models, as they become larger, they can learn a lot of things, but it requires data to train them. The metrics that we take data or training is, or the term is called a token. Token is not exactly the same as word, which we'll be coming to later. But as per some of the researchers, we require 10 to 20 times the number of tokens as the number of parameters that we want to train it to. That means we are talking about tens of trillions of tokens of data across these languages if we want an real Indian LLM that can actually do the type of task that we expect it to do. The largest open source corpus of Indian languages data that I am aware of at least runs into tens of billions of tokens only. The second thing that we talked about is about Indian culture. I don't have any problem anyone calling me black or brown or whatever color. I take pride in that. But if anyone calls me a blue painted god as white, I may have serious problems. So my sensitivities and the sensitivities of my Bharatiya might be different from the sensitivities that is aligned to the Western world. My India is large. My Bharat is even larger. When I go to travel to Bharat, even outside work, it takes me some time to start understanding what they are speaking. So in the process, I have acquired to speak at least 6 to 7 languages. If not speak, at least understand a bit and part of it. What confuses me more is, if someone starts something in Kannada, they include a local dialect of Tamil into it. I ask them a question in my broken Hindi language and confused English on top of it. Then it becomes a very complex soup. If I put this soup into even one of the most modern language models, it may not make out clear, precise sense of what I'm trying to do. People try to solve similar problems by translation. They take the English corpus or some other Indian corpus and they try to translate it into the specific language that they're trying to train it to. Research has already shown that this type of techniques doesn't scale too much. So how do we approach these many challenges in the Indian context? Now, when I went to some of the social medias, by the way, I'm also a stand-up comic, and the comic world, there's a lot of hue and cry that women, especially Indian women, especially when they become wives, speak a lot. The other trend that we see is that when they become wives, their participation in workforce come down. So God has given them a gift that we do not treat as a gift. And these are the unique opportunities when we start recognizing these type of challenges. The other approaches are more technology bound. For example, recently we launched something called a Nemotron 340 billion parameter model. Anytime a new model is launched, people will go gung-ho about it, will try to understand which other model it beats in which particular benchmark test. For the first time it happened that people were not gung-ho about that this particular model defeated or surpassed these 10 models in XYZ benchmark test, but they were gung-ho about there's a model which can generate synthetic data better than other synthetic data generator models, and that data might actually have more relaxed licensing terms in training their own large language models. So basically, if India wants to create that sort of a foundation model for its Bharat, then it's not going to be in one particular step. Research has also proved that, at least for these large language models and large foundation models, you can generate very good quality synthetic data that could be used to train them optimally to a particular ratio limits. That ratio could be 1:7, 1:10, sometimes in extreme cases even 1:100. But for that, the upstream generator model, which is generating this type of a language, should be capable to bring that sort of a diversity. Which means now we are in an iterative cycle. We are not talking about one foundation model for India, but a series of hierarchically more complex, more sophisticated foundation models for India. Just to excite your left brain even more, GPT-3, around 340 billion parameter model, not a mixture of models, but only one single model, took 10,000 GPUs running over several weeks to train that one single model. Of course, we have come a long way from there. The GPUs that they were using, now we have come to the level that we support that sort of a compression of the models, so that the same model could now actually sit on smaller number of GPUs. They are faster, we could require less model. But now we are talking about much, much, much larger models as well. So one thing that we have to get into is how much can we compress a model such that it can fit into the most recent technologies, and those most recent technologies also have to advance, and for that the research alignment between whoever is building the foundation models to whatever researchers are there should be in close conjunction such that the researcher can take a lead over there and come up with that architecture that can just not scale to a 16-bit model, but to 88-bit model, to 4-bit model, and even to the realm of what is now called as small language models or SLMs, which goes into 4-bit, 3-bit, sometimes even 2 bits. Because we are not talking about a resource-rich country where at least even the government can afford tens of thousands of GPUs. The small enterprise that has to host them might not be able to do that. The model should have these much features that it can fit to that latest infrastructure. The other challenges that we talked about is the cultural diversity. We have at least 3 members speaking about the different cultural diversities that India has compared to other languages. We also talked about safety. We also talked about sensitivities, which is very different from the Western world on which these models that we use today are trained. There is a specific process called alignment. We talked about reinforcement learning, some of the panelists talked about. That is just one form of alignment. There are multiple forms of alignment that make a model be more aligned to our sensitivities and our preferences. Reinforcement learning in itself is a computationally gigantic task. The reason why today's planning in large language models happen through large language models which are based upon transformers and not reinforcement learning, which was primarily acted as the, you can say, spearhead of the agentic environment. Anywhere you would require an intelligent agent, you'll use reinforcement learning, is because of the computational complexity. Plus, in its native form, reinforcement learning requires a lot of human involvement to grade the data, give them scores, how good, how bad it is. These are not just the real challenges for India, but each of this is a real opportunity also for India. I see one section of the media which is very paranoid about what will happen to our work culture, our jobs, if these large language models actually scale. Something that is imminent, you cannot stop. You can only delay. That too, you can only delay for the region that you are in. World will not stop for you. This is more dangerous for your jobs than finding out the alternative opportunities that these type of trends lay before you, and use the demographic dividend to open up new streams, new types of works where India can scale with them. Thank you.
Thanks, Mohit. Staying with you, if I can just corroborate on the fact that, you talked about, number one, go multimodal. That means you are suggesting IndiaAI should be multimodal with voice as one of the major factors. Second is that relying on collected data may not be the absolutely right approach. We need to also collect synthetic data or build synthetic data, which is there. And third part of it is to look at miniaturization. Model miniaturization should be a very big research activity which should go on. And of course, the fourth one, which is more in the terms of adoption, that you cannot stop this revolution. It will happen. The best way is to, see the potential and see the challenges and start, preparing for it and working towards it. So staying with you again, the next question which I have for you is that, what is your view in, the challenges being faced by the startup ecosystem in working with LLMs? And how can India Innovation Mission work towards solving that? That's, if you can throw some light on that.
So there are multiple challenges that I see Indian startups face. And by the way, in my role, I work with a lot of startups and a lot of different organizations of different sizes. And my role is to help them out, make a sustainable business with Gen AI and AI in general. So I see actually a lot of different startups from a lot of different types of streams into artificial intelligence. One main thing that I see is competitiveness. How these large language models are posed today favor a Western company more than an Indian company. This may seem slightly extreme, but let me again excite your left hemisphere to put these tokens. Now we talked about tokenizers, tokenization vocabulary a bit back, and we talked about GPT has 1 lakh tokens, and GPT-4 has 1 lakh tokens, and GPT-3 has around 50,000 tokens, 54,000 tokens. But even GPT-4 is trained around 23 languages. I think some are 2, 3, or max 4, 8 are in Indian languages. If you take a text, if you say take an English text, you put it into a token computation system. So many of these languages also provide you a portal on which you can compute how many words compute to how many tokens. So these models talks in the language of tokens. Any pricing or any compute that you may require, you would actually be asked one question, how many tokens you are going to deal with from an input perspective and from an output perspective. The reason is that the computation has to scale at the rate of square for each additional token. So then it matters in my language, if I'm giving it 100 words, how many tokens those 100 words would be computed to. That will determine how much cost I am going to give to take the same advantage from a large language model or a managed service or a compute from that perspective if I'm using any model that is trained on a Western language or predominantly Western language where the Indian representation is not there. Again, throwing some arbitrary numbers, you can check the exact numbers over there. These will be ballpark. So if I'm taking an English text and I'm asking how many tokens this 100 words in an English text will contribute to, I'll get roughly around 130 to 150 words, depending upon how rich those words are. This is for something like a GPT-4. GPT-3, if you put the same thing, because its vocabulary size is less, you will come to a larger limit. If you start putting Indian languages into it, even the most popular Indian languages that we know, this can go up to 3 times. If you start putting the language that my Bharat speaks and the dialects that they speak in, they can go up to 7 times. Which means my Bharat has to pay 7 times more money. And the businesses that support my Bharat has to incur that much more cost than a similar business outside for which these models are trained. Now, if I make a foundation model for India, which is trained on the languages of my Bharatiyas, not just the language of my Indians, I can substantially bring down this cost. This is just the challenge number 1 that I'm talking about. Challenge number 2 that I see with the startups in India is that of sovereignty. Atmanirbharta. Again, I'm making a very bold claim, a very extreme, not even a claim, but a point, but let me support it. I've heard many people here, and outside even, call some of these models as compared to GPT, the other models that we see outside, as open source models. I am not aware of any, or at least many, open source models. Open source terminology means that the source code is open, anyone can take it and build of its own. What you call as these models is an open weight model. Nobody is giving you the source code of these. They are allowing you to use the weights, and they are giving you some source code that you can use to fine-tune or adjust some weights such that you can make some tasks better than the normal task that exists. If you see the licensing terms of these models, of course, this can change from model to model. One is that you cannot use it if you grow above a particular user, a particular amount of revenue, and so forth. There could be other terms. For example, whenever you use some of these models, you have to always tell this has been made by this Western corporation, and this is the model name that we originally used. You lose your identity. The third is you cannot get into any business that competes with them. Just because my India couldn't afford a foundation model, I have to pay it through my sovereignty by adopting these terms. So right now we'll be calling it as an open model. The third type of challenge that I see with Indian startups especially is the integration between research and development skill sets. In the Western world, any of these models, the larger organization, whoever came up with these large language models, didn't came up with a very intrinsic research enterprise partnerships where most of the decisions are being taken by the research and the corporations fund them. That model in India is not very strong. It needs to come stronger. Currently, government is supporting the researchers and then giving the researchers a leeway, where some enterprise at very low cost is trying to attract some of the minds, but not at the level of architectural decisions of changing the entire model and investing millions and billions of dollars into their decisions. The fourth challenge that I am seeing is on the architectural and the development landscapes. Of course, there are government is running programs on skilling India, but as I said, the more these models will come, we are the IT powerhouse of the world. But we are in a sad situation that for our own startups, maybe some larger corporations can afford these are high-trained people, but for the smaller organizations, they are not so blessed. The type of architects and the developers that they could afford, they have to invest a lot into it to get to the level that they can deal with modern GenAI architectures, which is much different from the earlier approach of deep learning as we used to do. So the approach that I see mostly that startups adopt is, this is my problem, this is my target audience, this is a solution that I used to do with them when I was building a chatbot earlier with conventional NLP. This is a part of NLP that I want to transform into GenAI, so let me use a GenAI service, either managed or through some of the open source or open model sort of a thing into it. This approach very slowly takes them into a vicious spiral where they cannot scale anymore without incurring a lot more costs than they would have taken had they taken a later approach. Which means now the foundations of the model that the biggest companies are using are at a much more advantage than even the startups. Or larger startups are actually a much more advantage than at a smaller startups. This again was a decision that was taken because there were not enough people to guide them. So these are the four basic challenges that I see with startups in India.
Sure, Mohit. I think, the message for India AI mission in that particular case is to create the foundation models which are inherently open and also encourage the startups so that they don't lose the sovereignty and incur the cost which they are incurring right now. Coming to the fact that there is a lot of indigenous knowledge as well as the expertise which is available, and Kalika, I'll come to you in that aspect that you in your research center created Jugalbandi, which was a combination of the indigenous expertise and other things which were there. How can this happen? How can we actually make this go forward or have a multiplier effect of these kind of things so that the indigenous expertise and knowledge which we have is inherently brought up into the LLMs?
Yeah, I think we need specialized data sets for this. We also need something that everybody has referred to as what I would call a federation of models, so that we have some kind of bigger models which are good at certain aspects maybe reasoning, or they're good at the conversational structure part of it, but then either these are grounded in knowledge bases, or there are fine-tuned models on certain kinds of indigenous knowledge which work in collaboration with these knowledge. So I think expecting a big model which will encompass everything might not be a very fruitful idea going forward, but having a kind of a federation of model and having some orchestration around it so that we can incorporate such knowledge bases into it might be the way forward. I mean, it's being done in small pockets. I think everyone referred to it in different aspects, but I think it's very crucial to incorporate, like you said, the indigenous knowledge forms into whatever shape the LLM takes.
Example, if we have certain knowledge bases with respect to the, curation or medicines, for example, which is there in the earlier setup, which is continuing through our generations, and it's mostly oral. How do we see that knowledge coming into the LLMs?
Yeah, so if it is mostly oral, then we do need to have some kind of either a voice database or some kind of a structure around, even a knowledge graph around it. And I know that there are certain projects in various academia which are looking at how to create knowledge graphs out of such, say, Ayurvedic traditions or other such traditions. I'll give you like a concrete example of like the Shiksha board that we did, right? We actually grounded it in Diksha, right? We needed it to actually answer, or the teachers to do, we created a Shiksha board as a lesson plan help for teachers in India. And in India, as you know, there are a whole lot of boards, and each board has a different kind of requirements, different kind of content, which is very well captured in the Diksha platform. And by using that as a grounding knowledge base, or also fine-tuning smaller models based on that content, right? You're able to give a much more contextually relevant information to the teachers, right? So things like that, I think, need to be explored much more widely in all kinds of aspects.
Taking cue from what Kalika said, Ganesh, in the aspect that, we need to basically collect data from the regional aspect. How does the regional dialect and the linguistic variations affect the accuracy of LLMs? Do you think that it affects, or what are the strategies we should be looking at?
Thanks, really enjoying this session. Bootstrapping around what Mohit said, and then Kalika, thanks for bringing up a lot of the traditional knowledge bases which need to be documented. In fact, there's so many dialects, if we don't document them in time, it's basically lost traditions, right? It's lost knowledge bases, not just dialects. Fortunately, in our experience in modeling, both speech and text, we found that there's a lot of commonality that needs to be leveraged. Yes, the miniaturization that you talked about, there's an engineering aspect to it, but there's also a deep research component associated with, as I said, syntactic similarity, lexical similarity, phonetic similarity, and this requires also to pay a lot of respect to traditional linguists. And we've done that in our Bharat GPT initiative. We've actually worked closely with several linguists who understand multiple languages. And I think this probably is what an academic industry collaboration is poised to do, because that's the bandwidth the academia gets. However, it must be grounded in industrial use cases, because if this again becomes a blue sky thinking without having deliverables in the form of foundational models, the industry will lose patience, right? Because for industry, I think what's very important is the AI promise should be delivered as an AI solution, right? And I really want to also allude to the point that Mohit made. I mean, we need to make sure these startups become cash flow positive. And I'm very happy that the engagement we talked about, Bharat Bhasha Tech, actually became cash flow positive in a period of 16 months by employing not just small language models, but bringing explainability by design. So we'll need to keep that in mind, even in the data curation process. It should not just become a white elephant exercise. So yes, at Bharat GPT, we have a very, very dedicated Bharat Data Sagar. And this is an invite to everyone in the audience, everyone who's listening. Please join forces with Bharat GPT on the Bharat Data Sagar initiative. Now, there could be cases where you just do federated learning, and that is one modality in which we land up learning some of our models. We've been doing a lot of research, by the way, with Google research, with Adobe research on miniaturization, being able to learn with small parameters through knowledge distillation, but also federated learning. So yes, that must be an exercise. But there is also a large population who would like to share data. But how do you incentivize the sharing of the data, both at an individual level and at an organizational level? Please work with us, because we need to ensure that no language and no tradition in India is left behind in this exercise. No knowledge system gets neglected in our pursuit of the large language models, because we also need to pay respect to inclusivity in this entire process.
Sure, so you're looking at Bhashadan version 2, which we did for some time back. Coming to Shalini, with all these discussions which we are basically looking at, the impact of this entire exercise, and if you attach a measurement to it, what could be that model? As how could you measure the impact of AI solution, and how are you attaching measurement parameters? Is there some thought on it, or do you think that it is too premature to actually talk about it?
So just a few weeks back, Nandan Nilekani talked about this, that India is going to be the AI use case capital of the world, right? That India will use AI much more because we have 1.4 billion population which is hungry to use AI. So success criteria is, I would say, is going to be defined by us. It's definitely going to be defined a lot by Indian citizens because they are going to use it, and usage comes only when there is need, there is value, and there is continued value, right? So if I see from AI perspective where we are in this technology era right now, whether it is startups, whether it is large enterprises, everybody is talking about the business value that you derive out of AI, out of Gen AI, out of models, out of the whole solution. So the business value that you derive out of it now, as well as on a continued basis, is going to define a lot of the usage of AI itself. It's a self-feeding thing. You're deriving value out of it, you'll invest more money into it. Because the more money can get into innovation, and your cost of doing the same activity has to keep coming down. That's exactly the concept of a cloud economy also, because the cloud economics works that the more cloud you use, that should actually bring down the price of using the cloud, so that your base is cheaper because of economies of scale, and you are using it for better value services or higher end services. So to give an example in this, I would say that the AI solution, what it cost. See, right now today everybody is looking at, they just look at the LLM parameter which comes out latest. It can cater to how fast it is giving an answer, or how soon it how soon it is giving, and how many answers it is giving, and it's how many parameters it is trained on. But the idea is the AI solution which an enterprise or a startup uses many more things than just the LLM. For example, it's a healthcare. So I built a healthcare application in which if you know, like 500 million Indians are supposed to have Aadhaar IDs, which is health ID, right? So each one of us need, especially you get 5 lakhs insurance in PMJ if you have that health ID with you. So there is a startup I worked with, Eka.care, and they create these health IDs. And then we said, okay, let's use Claude 3.5 and on Amazon Bedrock, let's use that and see how we are able to improvise patient care, right? And when we say patient care, we said we'll take lab reports of people like you and me, and we'll see that what are the trends that we are seeing, that based on markers going up in kidney markers and blood markers, what is it that we can predict about the person, and what is the disease that that person has, right? So we used all the features. I mean, if you know that today in the latest Claude models, you can do mathematical analysis and you can derive a lot out of graphs out of it. So the medical lab report has that. It has a report, it has graphs, it is showing, if you feed like every 3 months, you also know the trends, right? So if you go to a doctor will take time, will understand your reports over the past 2 years, and take time to advise. But there's a lot of information which is already available in the medical system, right? In the hospital, that a kidney, what are the kidney diseases? What are the markers which talk about that, if this marker is down, your kidney function test is giving some number, then this is what you might have, right? All this is medical knowledge, and that's actually what doctor is applying. Now, if the same doctor has to cater to multiple patients, not just one. So if the AI, and we made a patient care model which can help the doctor, not be the doctor. Again, I'll mention that. Not be the doctor, but help the doctor. What we realized in this solution is, we use Claude 3, we used interaction mechanism, we used knowledge bases, we created a knowledge bases, we created agents. So agents are basically tasks which which you can automate using AI, right? Very in simple terms, tasks which you keep doing, repeating again and again. For example, the computation and finding out a kidney function test has this number and it means this disease. So we created agents, we created vector DBs on most of the information available in the hospital. What we discovered is actually the cost of the solution can come down if we decrease the reliance on LLM. It's so contrary to what we hear, right? The more LLM you use, the better it is. The cost of the solution will come down if you decrease the number of calls you make to LLM, because you have used knowledge bases, which is the knowledge already present. You have used vector DBs, and you're using LLM, yes, for question answers, maintaining the context of what the interaction is going on. So essentially this is, the cost of the solution is important. The doctor is going to use this solution only if it answers well, plus if the hospital will not deploy it for the doctor if the solution is taking huge compute, it is taking multiple time to fine tune a model. People don't have that much time and energy or cost or effort to waste. So the cost of the model, the architecture of the solution, and the decrease in the reliance on the most heavy compute intensive thing is what is going to define actually the usage of the LLM model itself. So that's the scenario which we have experimented, and most of the startups who work with us, they work with this in this manner, that LLM is part of a solution. It is not the solution. Using multiple mechanisms and using a larger Gen AI solution, which is a solution and not just an answer of an LLM, is going to define the usage and define the benefit of LLM, and hence drive the usage amongst all citizens. So that is one very big metric. The second metric is also a lot about the false positives, the biases, the toxicity filters that need to be in place, because those are I would say the hygiene factors. If those are not there, people will just rejecting it completely and not trying to derive value out of it. In fact, it's a very interesting thing. When I wrote my book, AI for You, 2 years back, nobody was talking about the value of AI. And I brought out a model called How Good Is Your AI? And how good is your AI? Good is a very relative term. And when I talked about a full model on it with ethics, bias, I think it was ahead of this time. People were not aware that the goodness will become so important that it will drive itself the usage of Gen AI. So these are some things which I wanted to share.
I got very excited with Shalini's example. We actually experienced this. With IBM Research, we built a model which is a mixture of knowledge graph and LLM. And that's going to be deployed across the entire Maharashtra University of Health Sciences. All the interns are going to use it. So I'll be very happy to talk to you about it. Thanks.
Yeah, thank you, Shalini. And I think, one size does not fit all, and we should be talking about end users and solutions. And of course, cost is an important factor. Because before I, open it up for question and answer, I think one last question to Pratyush, having developed the Servam AI and other things, how, the issue of intellectual properties would be handled in LLM? Like, you have open system, which you talked about. How will you handle it? And this is something which has been a continuous question because of the cost factors attached to the licensing part of it. So if you could throw some light on it.
Sure. No, good discussion so far. The intellectual property, I think, is more about value protection. So it comes down to where is value created, right? So we have been talking quite a lot about these models being repositories of knowledge, right? What is the culture it represents, what's the language it has, and so on. But from usage of these models to create value, they will be seen as reasoning engines, right? They will be seen as engines which you combine with other computing practices, like we heard about knowledge bases, we heard about semantic search on vector databases. There would be standard coding practices where code is written, and then there are these models, and even these models are not fixed in nature. They are fine-tuned, they can be continually pre-trained, like we said, they could be miniaturized, it can be combined with multiple modalities, voice and so on. So my sense is the base layer of the main foundation model should be thought of as a off-ramp for many people to then create value on top in solving real problems, right? Because though there is a lot of optimism on building these models, we have to be very grounded on which company building for which user or which government body building for which citizen is creating real value, right? I personally believe that this technology is such that the value for 1 rupee of compute on cloud or on-prem or on mobile, doesn't matter, has never been so high. What you can get for 1 rupee of compute that you can spend is remarkably increased in the last few years, and it will continue to increase, right? So there is value to be created there because there is a deflation in the cost of value creation with computing, but that needs to be created. It is not, I think the ChatGPT experience makes us feel like we are dealing with a product that is ready, that is one, that is singular and does everything, right? But the reality is value will be created when developers, when governments build extremely useful solutions with this, and that will involve domain, that will involve fine-tuning, that will involve other things on top. And I fully echo that it needs to be voice-led, it needs to be very efficient, it needs to respect our language characteristics and so on. But we also need to look at industry and what industry needs to do with these models. For example, we talked about LLMs more broadly, we have spent quite some time on language, but what does manufacturing do with it, right? How can you make manufacturing more efficient? India wants to become a manufacturing powerhouse, right? So how do you use it there? We talked a bit about healthcare, but healthcare is such a large space, right? And we are so deficient in terms of manpower there. How do we do there? So I just want to re-emphasize that there is actual deep innovation required in building value on top of these models, and that could be incentivized.
Yeah, I think that's a very important point from the perspective that you can have, we can perhaps create foundation models as roads, but the destination has to be those vehicles which we have to do deep analysis with the industry sector-wise going forward. Now, our time is up, but a few questions which we can take up from the audience. Please identify yourself and put up the question. Identify the panelist whom you are asking and put up the question, please. Yeah, so can there be some mics, please? I think some hands are getting up here. The lady in the front.
I'm Mona Khandar. I'm Principal Secretary, Science and Technology from Gujarat. Mohit elaborated a lot on how Bharat is more spoken than written. So that reminded me of one Bollywood movie called PK, where Amir Khan demonstrated that how the way the word acha is spoken leads to different kinds of maybe 10 to 12 different meanings. So whether that part has been taken care of or that has been considered. And the second and more important thing is, how it can be made like very effective solution. So when we say that, whatever model or solution is developed, but when it is utilized or used for a particular person, now it depends a lot on what could be a right response for that particular person at that particular moment. Because I might be generally optimistic, but at that time I might be pessimistic. And then government carries out a lot of extension activities in healthcare, in agriculture. So it involves a lot of change management and transforming or making people aware about what are the right practices. So generally, it requires a lot of what we call EQ, emotional quotient, to understand the person's mindset at that time, engage the person, and make that person aware about what is right and what is wrong, and then finally convince the person to adopt whatever government might be thinking should be right practice. So this adds to the complications. So how that can also be built in?
Very good question, and thanks for asking this question, because this broadens up a lot of things into how we are envisaging our foundational language model to be. There are different approaches that you can use to get the voice into a language model, or a language model to understand the voice. Traditionally, what was done was through mechanisms which are called ASR and TTS, which is automatic speech recognition and text to speech. Which means now if someone is speaking something, I will convert that into text. And for me, now it is text. I can put it inside my language model. And if my language model is giving me text out, I can put it again into this TTS engines and convert that into text, which is different from having a foundational model which understands audio, to be more precise, understands speech. The difference between audio to speech, to the type of complexities that you brought, the way, the accent, the emphasis that I put on different syllables can dramatically change the context of that particular word. Which means now I am not just talking about the phonetics of that particular word, I'm talking about the frequencies of the words and the amplitudes at every frequencies of those words. Which means now my language model, or in this particular case, this multimodal model, has to understand even that as a vocabulary of itself. This is where the context that I initially brought in, that my Bharat is more comfortable speaking. You cannot give it a text model, apply TTS and ASR to it, and call it a language model. That is now how my Bharat communicates. You are making a text-based model turn into a language model, not a communication model. That's point number one. Point number two on how do we relate better to what a person is going through to actually create responses that more relate to what he may or she may like to hear. Or more precisely, to be communicated to, not just hear. There are three different mechanisms to it. First is, can I take this multimodal foundational model, or this communication model, as I say, also to understand my body language? What it takes to do that? You may say that body language is just a matter of a particular image, but body language is more than that. If I frown, that frown may go to multiple frames of that particular image, which means now I'm talking about video. Then we talked about not only what is coming on my face. I may have so much stress right now, I'm just trying to stay calm and answer this question. That stress is in the context of my knowledge bases that is around. So can my large language model or multimodal model can also consume that context, have a real-time interface of my face, the body language that I'm speaking, the accent that I'm speaking, the emphasis that I'm speaking to different words to understand what do I really mean. And then it's large enough, has so many parameters, can think to the level to understand what should be an ideal response to a person who is going through all of this context, is in this mode currently, that would be an optimal response to this person, and not just a text spitting out.
Right, so, as you could understand that when you are talking about the communication, which is the oldest thing which we do, which perhaps hundreds of years back, some people discovered this and it has evolved over a period of time. All the problems will not be solved in a day, and it would actually have a step-by-step resolution to everything which will come across. So Good that we are aspiring to solve everything, but yeah, it would be slow and steady. One last question which we can take up, although there are a lot of hands up, but okay.
There's a question to Dr. Kalika. Of course, anybody can take it. I'm Sivaramakrishnan, a GPay member from UAE. You spoke about knowledge base and graph databases in the context of LLMs. This was there before, I mean, as a research initiative. In fact, I worked on that about 5 years ago. Why do you think this particular area of interest is gaining popularity, and what are the specific sectors in your experience, what you're seeing now? I mean, you're vehemently getting into this. Is it a flavor of the month, or what do you think?
No, so I think one of the reasons, at least from my point of view, and I would like others to also weigh in on this, but one of the reasons is that, what we've seen is that consistency is a problem with the larger models. Hallucination is a problem that we haven't actually even touched on. So what is it that we can do to right now, what is it that we can do to ensure consistency, to constrain the models, to not just go off the rails and start talking about something completely different, and what can we do to ensure that there is some correctness involved. And I think right now, I mean, there are other ways. There's research happening, and research outcomes will take some time to actually get out in the real world. But I think right now, one of the best ways is to have these kind of knowledge graphs or knowledge bases to ground the outcome of the model, the larger model. So I think the reason you're hearing a lot about it, I mean, it may be the flavor of the month till we find how to concoct the next flavor. And we are working on several flavors as a group. I'm sure we are working on several flavors for this. But right now, this seems to be the most reasonable approach going forward to ensure that we have such kind of consistency.
Yeah, so I think we will have to close the discussions. Panelists would be available because I'm continuously getting messages that the time is up. So thank you. I think I enjoyed the discussion, and I hope you also enjoyed it. A big round of applause for all the panelists. And thank you very much for patient listening.
A big thank you to our esteemed panelist and moderator. Your expertise, perspective, and thoughtful contribution have provided us with a wealth of knowledge on various aspects such as diversity in India, the data biases, or how model mixture is important for efficient outputs. Now, before closing the session, I would like to call upon Mr. Nag to please facilitate the speakers and the panelists. Thank you, Mr. Nag. Now I would request Sri J.L. Gupta, Director, NEGT, to please felicitate Mr. Nag. Thank you, everyone.